All right, here we're going to graph this inequality. This inequality has an x and a y, so there's going to be a solution that includes x and y's. There's actually going to be lots of solutions, so we are going to graph it to see what those are. So in order to graph it, it needs to be, you have a graphing calculator, you can do that, or if it's in slope-intercept form, you can plot the y-intercept and use the slope to come up with more points. So this is not in slope-intercept form, so I am going to change it. So it is y equals. So I'm going to move the 3x to the other side. When I do that, I have negative y is less than. Since this has the x first, I'm going to just change the order. Think of this as positive 2 and negative 3x. So instead of 2 minus 3x, I'm going to say negative 3x plus 2. And now I'm going to undo this negative here by dividing by negative 1. And I need to divide this whole side by negative 1. And that cancels that out. Remember, when you divide by a negative number, the answer is going to, or you have to flip the sign. So it was less than, and now it has to be greater than. And you need to divide this whole side by negative 1. So if I divide negative 3x by negative 1, negative 3 divided by negative 1 is just positive 3. And then if I divide positive 2 by negative 1, it's negative 2. So now the number here is my y-intercept, and then the 3 is my slope. Slope always has to be written as a fraction. Remember, the top is how much you go up or down, and the bottom is how much you go left to right. So you want to think, how do I write 3 as a fraction? 3 is the same as 3 over 1, and it's positive. So we have everything we need to graph this. So let's just plot our y-intercept at negative 2, and then I'm going to use the slope of 3. So it's up 3 over 1. Since it's positive slope, I want it to be going up. That's positive slope. This would be negative slope. So I'm going to go up 3 to the right 1. I'm going to keep on doing that. Up 3 to the right 1. Up 3 to the right 1. Or I could have gone down 3 to the left 1. Down 3 to the left 1. So I have some dots here now. And I need to decide, do I do a solid line or a dashed line? Since this is just greater than, it's not greater than or equal to, it's just greater than, then you do a dashed line. So just kind of do the best you can. There you go. And again, if it was greater than or equal to, then I would make this a solid line. Now I need to shade it. So if it's greater than, you want to do above the line. So if you kind of look at this purple line and see it as a slant, if you pushed that purple line down, that would be below. And if you pushed it up, that would be above. So above the line is all this over here. You see? So again, focus on the slant. And if you were pushing down underneath the slant and you're pushing up, that's up. And if you're going above that purple line and smashing it down, that's below. So all of these are the XY answers that are the solutions to this inequality. So I can look at this and decide if something is a solution. So like, for example, if I said, is 4-1 a solution? So you could go over 1, 2, 3, 4, up 1, and see, nope, it's not in the shaded area. But negative 1, 4, over negative 1, up 1, 2, 3, 4, that is an answer. Or this is an answer. All of these red dots over here in the shaded area are solutions to this inequality. Lastly, I want to point out, if it is on the dashed line, if it's a dashed line and it's on the dashed line, it is not a solution. If it was a solid line, if this was greater than or equal to 3x minus 2, that line, it's equal to everything on that line. So any dot on a solid line, it's equal to that line. But a dashed line is saying, okay, it's not equal to that line, 3x minus 2, but it's everything above it, okay? And there you go.